Okay, it's recording. Go ahead.
Cool. Thanks everyone for joining this meeting. This is a bi-week meeting, and last time we talked about the metadata structures. After that session, I actually filed a PR for that. I put the PR link here. Not sure if everyone already take a look. So this PR is based on our discussion in the last few weeks, a few months, and try to simplify a little bit by combine the signature and overloads together with the one structure. At the same time, we provide a list of version for each individual overloads, so that we don't necessarily copy all these things to the next version every time. We just make a tiny change to one overload, change property or change one of the definition of dialects. So then I can actually run through this if you guys are okay with that, or I can answer any like high level question if you have any question at this moment. Let me share my screen a little bit. Sarah?
I have a question because I didn't attend all of them. Maybe you guys already discussed. I reviewed the PR, but I don't see any implementation. Who's going to return the implementation? I don't see any section about the implementation, basically.
Yeah, at this moment we have not had any implementation yet. So this is a spec only. We're gonna also need the REST spec, because this is I think without REST spec it's still will work, but REST spec is kind of very important for the REST catalog, given the popularity of the REST catalog. So yeah, we haven't have any implementation yet from client side or the server side.
No, but I'm trying to say that maybe I miss it, the express that we don't return any UDF implementation on the spec, and the how the user, let's say that we implemented this spec, how the engine will get the UDF itself. There is only SQL expression, but no Java implementation, or let's say that C++ implementation, whatever it is for that UDF.
Yeah, I think this is gonna be similar to what a view or table, event table does, and we have, for example, in terms of the REST catalogs, we're gonna need some the function catalogs, so that you can use that Java or Python client to grab that. Either you load that function, or you try to create or update that function from the client side. The SQL integration where happens in each engine side, that part it's actually a little bit tricky, because each engine has its own VDI for the UDF. We might need a certain change from engine side. Hopefully it's not a big change. It's going to be minor.
Okay, I will think of with you offline. I didn't get that, because in my view there should be a path, like bucket path, and the engine can download the UDF on their local or their class path to use that if the UDF is not available for the engine. That's why I asked that, but it's okay. Maybe I missed the point.
I think in general, load an UDF is like load a view or table. You load the whole back of the metadata file, and then engine makes decision what to do. Pick one of the overloads. For example, if you have like your input is float, but you only have int, whether you want to do the custom. Sorry, the other way around. Your input is int, but you have only have the load overloads, and whether you want to do the casting or not, it's decided by the engine.
Yes, but let's say that I have geolocation UDF, which is not available on any engine. Where I am going to locate that UDF according to spec, I couldn't see that any UDF actual implementation path on the spec.
So my take it for UDF effort is this is users' responsibility to create UDF in their catalog. And once that UDF has been created, for example, if you have multiple engines, you needed to create multiple dialects for each of the individual engines so that this engine could use the UDF. It's users' responsibility to make sure semantically they are same. And once the user create this UDF, the engine would be able to go to the catalogs, so go to the namespace and find that particular UDF.
Okay, we will serve that UDF on the catalog.
Yeah.
And the catalog will have the UDF implementation path.
Definitions, including the body.
I see. Okay. Thank you.
Yeah, thanks. Any other question?
I have a question about the table functions, because I saw that was added and I put the question on the PR as well. I was wondering if someone had any more information on what that's supposed to look like for like return types, because I guess I was a little confused on what the difference between a UDTF and UDF would be, except for like return types.
I think, part of it may be where it can be used, right? So table types can be used in a from clause, whereas if you were just going to return like rows or something else that represents values, like you can only use those in explode statements, I believe, or like a nests.
So is the return type then though an identifier? Because what is the UDF actually return?
I think a UDTF usually returns us a collection of rows with a schema, right?
So yeah, and when I said that is like, isn't that just list struct, or?
That's a good question. Like in other implementations, I know they're called out as like a separate like interface. So my recollection only comes back to Hive. So you have to implement a different interface for it, as opposed to just returning an array of, struct or something like that, or array of array, depending on what the implementation is. But that may just be an implementation detail, right?
I think
to know where it's used.
Because like then, I think I understand, like in that context, it would have to return like a table object. Like it couldn't be, it has to be something engine specific for the engine's like understanding of what a table is, right? Like it can't just be, it feels like a different beast.
Well, if it was returning a struct that has named fields, right? The only problem then is like, you have to know what those fields are. So it has to be predefined so it can use it during the analysis phase, or I don't know. Like what?
I think it needs to be predefined.
Well, so that's actually difficult because we may want to look at what some of the table functions are, but this may get too far into the weeds of like how we would specify it, because like you need to be able to get the named fields, but I think a table function doesn't necessarily need to have a fixed set of fields for the function itself. So it isn't necessarily part of the signature, right? It isn't like, hey, the return has a well-defined struct. It's that the return is a list of structs that have consistent fields, but I don't know that they need to be fixed. So then the question is like, well, how do you tell the engine, how does it interrogate the table function to know what fields exist?
Yeah, exactly. I mean, doesn't that imply that you need to know the output of the UDF ahead of time?
You need to know the output in some way, but I think that's an interesting question. I don't know if that's something they do at runtime that you can interrogate the function. Hey, based on the inputs, what are the outputs, or if it's just fixed. And I think I would be fine just saying that, like, hey, if you define a function, you have to define the explicit schema of the return type, right?
Yes. Yeah, that's what I think that's a reasonable restriction. Because
Yeah, right.
what you're probably wrapping here are like you're essentially having parameterized view or selects, right? You can think of a UDTF as that. So, select A and B from some table where, and then you have a where clause that's basically filled in by the parameters of the function usually, I think.
Yes, the current design in this PR is predefined UDTF schema. I think Russell's question is whether we can we don't need this flag at all, because this flag I designed that as the flag to indicate whether it's UDTF or not, because if it is true, then the return type must be a structure, then it will return a number of the from 0 to like n number of the structure. I think Russell's point is, could we just use a list of structure to describe that a UDTF and without this flag?
I guess I'm also interested in, like, is this a concept that has implementations in other engines that, like, we can actually like plug it in? Because it feels kind of like a subquery, I guess.
So Spark and Hive both have a concept of a user-defined table function, right? And they do, I just checked, they do have a fixed predetermined result schema, okay? So that avoids any complexity of like having to figure out something dynamically. But I think that the difference is you don't define that result schema as a list of, I think that's implied from it being a table function. You're just providing the schema of the return type.
And it internally can treat that as if it produces multiple rows of the struct. It just doesn't. Okay.
And I think it's specific about like where you can use that within the SQL, because like, you can't just take a UDF that returns a list and use it in a from clause, right?
Yeah. I do think maybe it's a totally different beast than a UDF from how we're describing it. And like, that's where I get a little iffy then on whether it should even be like a parameterization of a UDF, because they fundamentally, one returns something and the other returns an object which could be iterated over or not. Because like a table, you can do a lot more to than just get one row out of. And I guess there's kind of like an implied non-serialization, right? Like you're basically implying that you could do a limit on this UDF and get less out of it. Like that should push down if we're getting a table and not a list of rows. Does that make sense?
Yeah, I mean, it would be treated like push down is obviously an optimization, but it would be treated like a table at that point, right?
Yeah, that's kind of what I'm saying. Like we're returning like a table object out of the function, not like a scalar result or even a complex type result. We're returning a table which has its own APIs that the engine can do stuff to.
Yes, but I think what the engine can do is up to that engine.
Yeah,
right?
yeah.
You to provide the definition of how to produce the data given some input.
Yeah, I guess what I'm clarifying is like it isn't actually like a list of something. It's like a whole, it's a wrapper around some collection of rows that the engine has to have some special way of like handling. It can't treat it like a list. It has to do something to it, I guess.
Yeah, and it looks like Talit is linking to Calcite. The Spark implementation has a table function trait or interface. I assume it's a trait, and it basically just is exactly that. It's the, hey, what is your result schema? And it probably has some mechanisms for pushing things down, like limit, maybe.
Mhm.
My understanding, calcite also return a row, which is wrap the other rows.
Yeah, that's just a type differentiation, because I think a few different engines like have a row type as opposed to a struct type,
Mm.
but they're effectively the same kind of thing.
Like as an engine, I would deal with it as a table and not as a list. And that's like the key differentiation here.
Yeah.
It's like it's a completely different thing. Yeah.
Yeah. I
So
think
that makes me want to split it out from UDF a little bit.
yeah, I think the other engine, I know Snowflake creates the difference with special commands for UDTF as well.
Yeah, I think they behave like correlated subqueries, but I don't really know the exact semantics.
Correlated.
So
I don't think that you can provide to be uncorrelated subquery, right? Because they are a thing. I don't know if you can put parameters. Maybe you can per row. You can address a table function or something. But
Well, I mean, you're basically producing a set of rows from a given set of inputs.
yes,
Right? So I don't, that to me, that sounds like correlated subquery.
I mean, I'm generating some unknown amount of rows from my input parameters, which could change. Like I can do all kinds of weird things. It's not like even a set. Yeah. The questions about like item potency and stuff get even weirder here because like I could have.
in terms of like, do we include this or not include it? It's still, I mean, it's basically the same thing, right? I mean, it is it's a UDF that takes an input and produces a result. It's just that result is handled specifically by the engine as a list of these things, something I can iterate over, as opposed to just a singular result. So, I mean, our options are we ignore it for now, or we and add it later, or we include it because it's similar enough to the other things that it's not worth excluding.
So I think that I would prefer to include it. And that's because we know that there are these functions that produce rows, some number of rows. It's not difficult to express that, right? And we're talking about wrapping a SQL fragment with a thing, that describes what it produces. So as long as we can describe what it produces and wrap the fragment, there's no reason not to include it.
So I guess my only difficulty is describing what it returns because I feel like that's a little more complicated because it's not a row or a list of rows or even a row iterable. It has to be like the subquery context.
It is a special struct, right? Basically.
No, it returns a struct.
Yes.
I thought it returned something that could generate many elements out of this struct.
No, I mean
many elements of struct.
So it return like the return type or the schema associated with it, the return is a struct, but it will return many of those if invoked, right?
But it doesn't like return them as a list. It returns them as a table representation.
But it isn't returning anything from our API. The API says this is the definition of this function, and then it is up to the engine to integrate that definition into its, the thing that these table value functions produce, right? So I don't know how that happens, but the information that we're capturing here should be something you can plug into any of these table valued function APIs.
Yeah, I think that's the only thing I don't understand enough is like what goes in these table function APIs, and is it universally defined enough that you could actually do this in like a sensible way? I'm probably, that's my problem, is I don't have enough information about what these actually look like in practice.
Well, we can definitely look into that. I mean, we can at least pull up the one in Spark, and maybe
Well,
the Trino, and
so maybe a better question, I think, is getting to what Ritzel is pointing to is like, can you create a table function from a SQL query? Because what we're talking about right now is a SQL dialect. So what does it mean to produce multiple rows given input purely in SQL? Like, I know what that looks like in Python. I know what it looks like in Java, but what would be the actual text body for a UDF in SQL that is a table function?
it's a select query.
It
So,
is just
yeah.
a query.
It's a select query.
Okay.
That's why I think it behaves like a correlated subquery, because you end up with this, sub select query thing, with parameters from your outer query.
And so that's different from a UDF defined in SQL because you can have a select query that returns a singular result, right? And that could be a standard UDF, right? Or it could just be an expression fragment, right? What are we allowing for the body of the UDF that provides a one-to-one input to output relationship?
So that's a good call out. I think we're probably more likely to run into problems there, because there's a very specific way you select a set of rows, in queries, but you could have a UDF that is solely specified by SQL expressions rather than SQL statements. And I believe UDFs can contain either statements or expressions. So if we want to say, like, okay, engine, you have to massage whatever you get in that SQL fragment area, the SQL area, then we should think about how to massage that. I'm inclined to do exactly what we did for views, which is to not touch the SQL fragment, not require that it be wrapped. So that means there's more complexity for implementations to say, hey, this might be a select and this might be a expression.
Mm-hmm.
But to basically with high confidence reproduce the exact fragment that the user passed in.
Yeah, I mean that makes it a little bit more complicated, because then when you're interpreting a UDF, you have to guess at what it might be. Is it an expression or is it a full statement? Could we just say, like, in a view, I think it's pretty much implied that it's always a full statement, right? It's going to be some sort of select query.
Yeah.
We could, I believe, and this would be good to validate, you could express everything in an expression in a select statement. So can we say it needs to be a select statement? Because, like, if you want to express max of input column, that's select max of input column, right? One's an expression, one's a statement. But can we express all of those things with statements, or do we actually need expressions for something? Just to narrow, like, hey, how do people need to interpret this body?
So this is where I think you're going to have engines that allow you to say create function, blah blah blah, and then max of whatever. So I think we want to take whatever the engine has and not require the engine modify that SQL and stick that in there directly. So that's why I would say support both expressions and statements, because otherwise the engine has to modify the statement to get it to something that can be stored. Does that make sense?
Yeah, I think the RLS is one of the things we try to let engine to do the validation on the engine side instead of the catalogs is doing the validation. in that case, I agree with Ryan. We probably let engine to make the decision by itself.
I think this is kind of something specific to SQL though, because there are other syntaxes used by different engines to define UDF. Some of them have their own custom syntaxes and everything. I think it would be good to look and see if there are any databases out there that currently allow the fragments like Ryan is saying. I just took that I saw our SQL, at least all the examples that I saw, like our full statements.
I thought there were examples in the original UDF doc.
But were they drawn from existing databases, or were they just like fragment examples of how you could define them?
I don't know.
Yeah, trying to find them.
Thanks, Talat. I feel like UDTFs look like macros to me.
Yeah, the only difference is that with the macro and the table value function, it doesn't know the value, right? It just evaluates on the runtime.
Mm.
So we do have examples from like Dremio of protect SSN, where it is a returns varchar and the actual expression is a case when.
Okay.
We also have like multi-statement UDFs that we have not really. I mean, there's a bunch of stuff in here that I don't know if we want to support as of yet, but it seems like as long as you have a SQL thing and then that produces a value, right? We can at least take those and make them the SQL fragments portable.
Okay.
So
I guess, like, I mean, if we want, like, rather than getting into arguing about, like, should we allow multi-statement SQL or not, we should probably just rely on dialect, and it's your job to interpret the dialect. And then for a dialect, we can further, define, or just let it be like, hey, if Spark dialect is what was selected, anything that Spark can interpret is fair game, and then it's up to anybody else to try to replicate what Spark is doing if they want to use that.
It looks like in this design doc, basically every example has a UDF that is just an expression and UDFs that are select statements.
Okay.
UDTFs?
Yeah, UDFs. I don't know if there are, I mean, I'd be surprised if it weren't that way, but it doesn't seem like there are necessarily UDFs that are not UDTFs that are select statements.
I mean, that makes sense to me. If I was designing an engine, my UDTF is basically, I think, like you said, it's basically a correlated subquery. It's a macro language for writing a query, and my UDF actually has execution logic in it.
Well,
it looks like there is a example UDF. Oh no, that's a table UDF. Okay. Yeah. So this is a good thing for us to look into, I think, before because if we do have a restriction like a UDF must be a SQL expression, that would be helpful to call out ahead of time.
I have examples of, like, I was looking at traditional relational databases, and most of the ones that I found were full select statements for UDF definition, not UDTF.
Okay, well then we've got more both.
Which is why I was leaning towards, you're right, let's just ignore what the content is, rely on the dialect and say, it's your job, if you say you support that dialect, to try and interpret whatever is in there. Because I think the space is just so large. Because there's also like macro, like Russell was saying, I see some examples of like very language specific macro definitions within that. So it's
Okay.
portability may suffer here, but
All right. Well, I'm
Yeah.
convinced that we need UDTFs, and also that they're all poorly defined, and it's going to be a nightmare.
well, I think
but
the reality is like people will just like settle on whatever the lowest common denominator is, right? If I can
That's what-
use like some, dialect specific macro, or I can express it in a SQL statement, I should probably use the SQL statement, right?
yeah.
If I want it to be portable at all.
I think that this is also an area where if you need a SQL statement, you check if it's a select, right? You try to parse it as an expression, you try to parse it as a select, and you can always wrap an expression in the select if necessary. If we are almost done discussing the UDTF thing, I would love to get, because the actual structure changed a lot since in the last 2 minutes of the last meeting, we changed the structure a lot. So I'd love to
Yeah.
get
Sure, I
to
can.
that, but we can also, I can take that offline if there are other things more important to discuss.
I have slight question before diving into that part. I know it will take a little bit longer. Are we going to support the user-defined aggregation function?
So when we define that, we're taking a table as input or some set of columns as input, basically.
It is column, but
you
you're
can-
representing.
I think we're not trying to limit UDF to non-sponsored aggregation.
Well, so there's 3 different flavors, right? There's one input to one output, that's a UDF. There's
Mhm.
one input to many outputs, that's a UDTF. And there's many inputs to one output, and that's an aggregation function.
Is there a significant difference other than flag, much like our table return type flag?
I think it's just like you just need to define what it is, because it doesn't really change the return type or the parameters to it, right? It's either a UDF, UDTF, or UDAF. And you just need to know that to know how to interpret the parameters in the return type.
Do we have an example of a UDAF?
Um,
I can
Like
share the
Max.
BigQuery example or any.
what is the, like, window functions are UDAF, so like in the example,
It's like I want multiple values from the same column as my input.
Yeah.
So I basically need like a subquery as input, and then I use every single row in that subquery to
I mean,
produce my output.
average, max, like those are all
Yes,
UDAF.
exactly.
So that, yeah, this is the other one, right? Like my little tingly is just like we basically change the input parameters. We don't change their type, but we change the container in which they come.
I would actually not do that. What I would do is I would have some sort of property that defines, is it a table function aggregation function? And then we just leave the parameters like normal. Because like if you describe a aggregation function, it doesn't say I take a list of these things. It just says, yeah.
Fair enough. I didn't mean we're actually going to do
Oh,
that. I meant like the engines are basically saying, when I see this now, those are the types, but I expect to get a container of them and not a single one. Same with output. I'm not outputting a single row. I'm outputting some container representation of a set of rows that has special syntax within my system.
Yeah, agreed.
We may introduce a type on line 7.9. We say that UDTF. Maybe we can say that a type directly, and we can mark like scalar, aggregation, and table function.
Yeah, I think the parameter would be different because we want to be a list of the, like that table, right?
I think that's fine. I want to change our docs on these to not be like what the return type is and explain the behavior. but that's about it. I think that's fine.
We can definitely do UDAF type, so that parameter will be a list of things instead of just a like single value when we consider the input, which is basically UDAF.
No, this is not correct. The signature is still single, but the engine knows that it will aggregate that result. Basically,
Yeah.
we should think like select, count, group by something else, right? There will be a list of the things, and they keep calling the same function.
So I think, yeah, I'm not clear on what this even looks like when you declare one in SQL, right? Is this like I mean, you could certainly have a,
We can look at the regular count function, right? For min max. Let me see.
But do they need to be a scalar value? Because when you're saying group by, it can return a list, right?
That's why I brought the thing. It can return the list of the rows also. This is
Oh
also
boy. I mean, that feels like a subquery again.
it doesn't
Sorry.
because it's aggregation, right? You are doing just it can return string which you can do the concatenation. It's the same list of the stack.
so what I guess, say we had like average, right? So average of column, and then you have, that bakes down into sum of column divided by count of column, right?
Mhm.
How would we, I mean, I guess you can express that. And then the engine would need to know that that can be placed in a substitution. But it would basically say like, okay, well, I see that this is used as an aggregate and it's composed of aggregates. So yeah, just do that substitution. I'm trying to find examples of SQL-defined UDAFs, and I'm not coming up with much.
So I feel like it would just be a
There
subquery.
is this is for BigQuery, but it's using also the aggregate. 1 second, I couldn't find my tab here.
It's like, isn't any UDAF just like a group by or a something like that, reduced by?
So it's funny. I'm looking at like what Postgres does, and it's complicated. So they have you create a function using SQL, and then you create an aggregate using that function as like they have this sfunc. So yeah, it's interesting.
Float accumulator final.
What is
This is
supposed to be?
This is also how the
Yes.
Flink is doing that.
There's like a state function and there's a final function or something like that, and like so it's complicated to do aggregation.
Well, yeah, most of the aggregates that I see are like an API for aggregation, where and I believe this is what we did, because we did UDAFs in Spark with the API, right? So you could plug in code that produces the UDAF. And there you just have this thing that can be called multiple times to say, like, you know, add data, add data, add data, and then you call produce result eventually, right? And then there's also where you can do partial aggregation and then combine those results through a merge, and then you can produce a result from the final aggregation. But that is not really how I would see this happening. Oh, okay, so state function, final function, yeah, state data type. And is this something you can call from SQL?
Yeah.
Okay, and those are like lambdas?
They're statements, they're SQL statements. So each one of those is either a predefined function. So you can say create function, and then you use the reference to the function name in this the aggregate create statement. Or you might be able to inline them, but I think you might have to define them separately. So like this is crazy complicated compared to like table functions, which like is effectively a select statement.
Yeah, we would need to, I mean, I would probably say let's leave this out for now, just because like I think the majority of what we want to get done, it can be done with scalar and table valued functions.
But it's
we
good.
Eventually want to do this though, right?
Well, eventually, yeah. I think it's good to like, if we want to make progress, I think this is a can of worms. So what we might want to do is just leave the type for, you know, the function of like aggregate functions undefined for future work, because it's going to involve likely other properties and things that you would have to define in the actual UDF specification, like these, you know, the initial function, the state function, the initial condition, like all this kind of stuff. We can tackle that in the future once we have the other pieces. So as long as we leave enough space for it to be defined, that could just be the next step in this.
Yeah.
Okay. The accumulator part is even more trickier on the state merging part of things. Sorry, just like touching base on the state management and how do we define state. We need to, I think, mark some fields as stateful fields, which will be used for merging, etc.
So let's
Just yeah. It's like,
Still, we can keep the this thing as a type, right? Then if
Yeah.
the engine is supported, like BigQuery is supporting that, then they can use it.
That's why I think we need a type for the function of like whatever the you know, either a table function or a, what do we call it, just a normal function, scalar function.
Mhm.
Yeah, type scalar, type table, type aggregate. I don't know.
Yeah,
If
go
there's a
ahead.
type.
Cool.
Right. I think we are done with UDTF and UDAF. Then we can move to the structure. Right. Ryan, you wanna raise your question first, or I can answer this one?
So like I think we talked in the last 2 minutes, we had, you know, kind of something laid out where we were happy with where everything was. And then we said, okay, well, now what we have is a structure where every version does a lot of copying. And so the idea was, can we denormalize some of those things? What I'm seeing in the current structure that we see here is a lot more movement than I was expecting. So I was just wondering, like, if we could go over the structure and how you arrived at this.
Yeah,
because there are some things that that are unexpected for me. So first of all, like we have definitions, and then each overload has versions. And then we have some other definition versions thing, which I think is probably that denormalized thing, but
yeah,
it would be good to go over that. I'm also surprised to find that the overloads, or like the signatures, what were we calling that before?
we
those,
call a we separate signature and overloads before, and right now I think I'm trying to put them together because each individual overloads were just attached to the one signature. Like if you change the parameter or return type, it's gonna be different overload.
yeah. So I think going through that, like this does make sense. You know, you have a section of overloads. Each overload has, you know, some version and definition of it. Like that makes sense. But I think just going over how this all works now would be helpful.
Sure. Yeah, yeah. Let me go through them. First, we have root. Under roots, we have definitions, which these definitions gonna have multiple overloads for this particular function, and each individual overload is gonna have its own signature in terms of the parameters, which is input, return type, which is output, and these parameters as well as the return type make this one overload fixed. Like if you have different parameters, say you increase, you change your types from the int to floats, or you add a new parameters, it's going to be another overload. So that's the point of the parameter and return type for one particular overloads. So every time you, for this structure, the parameter and return type is immutable for this particular overloads. The things could be changed or versionized change is the representations where you can add one dialect or update one of the dialects. And every time you change that, then a new version is created for this particular overload. Then this is the one particular overloads. You can do the same thing to other overloads. Then try what we designed here to try avoid the copy every overloads in terms of just one dialect has been changed for the whole definition, is to have we call it definition versions. And for this definite versions, basically it's a list of overloads ID and its version. For example, here we can say for overload 1, we have we are using the version 2, and for overload 2, for overload 2, we get a version 3. And this is a list, including its timestamp and definition IDs. And we have a current version, definite version pointing to the latest one. Then on the top level, we still have the secure property and a backup, basically a backup of the open property for this particular function UDF. So this is basic structure, and I can give you a concrete example. I'm put here. So this is one function with the same name, but two overloads. So if you can see here, and there are two definitions because there's two overloads, right? Two overloads. So for the first overload, it has its parameters, which is integer type, and return type is integer as well. And it has two versions for these overloads. The first version always is wrong, which is add 1, it add 2. And the second version correct that with the body. Then that's the first overloads has been wrapped up, and the second overloads here, it's a float type. Input is float type, and the return type is float type. So it only has one version, which is x plus 1.0, and then we have, as I said, we have these definition versions, which were pointing to these two overloads. And we got two of them because every time we made that change, we generate new definite versions. So first versions point to the overload of 1, version 1, overload of 2, version 1. And second version is point to the overload 1, version 2. And for overload 2, still version 1. And it has own version handlers, which is a long or integer. And this is the top level, which point to the latest one. So this is pretty much like the snapshot versions, which we have a current snapshot ID point to this snapshot ID, this ID.
So I like the definition and overload and versions on the left-hand side of this. I think that is starting to make a lot more sense. Like it was a little awkward before when, there was so much change. So I like that you can go find, your overloads, find the overload for your particular situation, and then go and see, what versions or definitions of that overload exist. The definition versions stuff seems a little like we're mixing a couple of concepts, right? There's the concept of like the history, right? So we might want to say what changed when, so that you can see at a given point in time what was the current definition for an overload. But it's also adding this sort of what is the current definition of an overload in that area, right? So I guess what I'm saying is it makes the most sense to me to go from the root and say, okay, what are the parameters I'm trying to match, and choose an overload, right? From there, I want to know for this overload, what is the current version? And so it would make more sense to me to have versions, but also current version in the overload on the left. Then that means the structure on the right, rather than being, because you don't really need lockstep versions, right? Like this overload corresponds to this other overload. Does that make sense? I think you do want to know, like, what was the state of this UDF at any given point in time, but that should be the responsibility of this structure here on the right. Whereas, like, for any particular use, you're saying, what is the current version of this overload? So I would probably say, versions of overload, and then you have a current version in the overload. And on the other side, you have this overload changed to this version at this time. And make that more of a history. You can reconstruct, like, for a given overload, what were the versions of the other overloads at that point in time?
Yeah, we can add one, like under each individual overloads, we can add one current version, which point to the current version of the overloads. So that from the ending perspective, I think it's, maybe easier for ending to understanding, okay, for these overloads, my current version is, let's say, V2, right?
Yeah, it just seems to mix concepts. If we're saying, like, all of the overloads evolve in lockstep, and then I need to go to this other, structure to see which version of all the overloads I want. Although I guess that would allow you to add definitions of the overloads and then, like, update them all at once. But there's nothing really preventing you from doing that anyway. Right. That is to say, like, I could add overload 1 v3, overload 2 v2, and then actually change the versions in a single definition version.
Yeah, that's basically the right side of the stuff, right? Every time we change the version for the whole UDF or the whole validate.json, we just change this particular version to record the it itself, like this whole metadata has been changed, right?
So I think the question then is, do we need to update multiple versions separately than adding a version of the overload? And my answer would be no. So I would say, like, current state of it should be in the definition tree, and changes should be in some logish structure to be able to record like what was current at what time.
Gotcha. Yeah, I think that makes sense. So basically, you wanna this definition version is basically it's kind of the metadata JSON logs, which is just for information, right?
Yeah, I think it's more like the snapshot log or the version log for views, right? So it's saying, because if you look at this as like views, then I think what we have here on the left aligns, except we have this overload level above it.
Mm-hmm.
Right? Because we have versions, and then versions have representations. And what we're saying is we have multiple overloads, right? So I like that aligns very nicely with views. And it's basically saying, like, okay, well, we have, multiple things depending on the number of parameters and what they are. And then we just have to have like this version log that makes sense across all the overloads. So I think this is actually way cleaner, but it's just a little odd that you would have to go to this other structure to figure out what the current version of a UDF is, when you really don't care. Like, if you're resolving a UDF, you're going to figure out your overload, and then you're going to figure out the latest version of that overload.
Yeah, I think that makes sense. We can definitely add one current version on this level, and this is more of the version history in case you want to mix, you want to trace the whole history, change the history. That makes sense. I actually have another question. Here we have open properties on the root level. And that makes sense. We have the property on this open property on this overload level, so that's open property.
What would the use case be? Because the open properties at the root level for tables and views capture like behavior properties for the entire object. So like keep this many versions or things like that. I think we would want to just have an idea of what we're placing there and what it can affect.
So one of the use case is, for example, here we use deterministic and as the kind of attributes of these representations, but some engines might have something else called volatilities. Like how do we allow this engine to express that on these not only the overload level, but also maybe representation level, they need a certain thing to express itself.
So to me, if it is a property of the thing itself, and it is an important property to track and to, look at, we need to figure out where it goes in this tree and update the spec to, carry that information. If it is informational, then you could stick it in properties. But like, I think we need to, I highly prefer actually having fields of the objects to carry important information rather than ahead of time making safety valves for us to stick properties in, if that makes sense.
Okay. Sounds great. So I can try to think about a more use case. If we need that new attributes, we can just add them into certain level, dialects or this level or this level. Cool.
Yeah, that's I think that it would be good to do that because this is stuff that, you know, if you have a volatility parameter or option, right, that's important information, and we probably want to, you know, just like the secure property, that should be you know, chosen at the right level of the tree and also added to the spec so that you can exchange it without just conventions in properties.
Makes sense to me. Cool.
All right.
Thanks, Ryan.
Yep, I'm gonna bail as well. Good to see you guys.
Yeah.
Thanks.
Thanks everyone for joining this meeting. I'll send out the summary a little bit later. Please take a look at the PR as well. Thank you.